The business case of automation. In a previous presentation, we discussed the ethics of automation. We touched upon the fact that automation projects you implement can significantly impact individuals, as some may lose their jobs if the project is successful. This happens because their previously manual tasks are replaced by machines, leading to an overall increase in productivity per worker in the factory or warehouse. As a result, fewer employees are required to maintain the same level of production output. I also mentioned that this phenomenon applies to any technological advancement that improves productivity, not just automation. However, automation is particularly affected as increasing efficiency is often its primary objective. When an investment in technology, including automation, proves profitable, we refer to it as a positive business case. It is important to examine the business case for automation in more detail to understand what drives such projects today. Before delving into the business case, we should first define what automation actually is. We will then explore the reasons why companies adopt automated solutions. While the most obvious reason is cost reduction, there are several other factors that play a role which we will examine. Finally, we will discuss how to assess the business case for automation. How can we determine whether an automated system makes economic sense? What is automation? First, let's discuss what automation actually means. Before automation, there was mechanization. Mechanization refers to the process of using machines to perform tasks that were previously done manually. A quote from 1861 that beautifully sums this up states, "Every machine is constructed for the purpose of performing certain mechanical operations, each of which supposes the existence of two other things besides the machine in question, namely a moving power and an object subject to the operation, which may be termed the work to be done." Machines, in fact, are interposed between the power and the work, for the purpose of adapting the one to the other. What Robert Willis describes is the fundamental idea that a machine serves as an intermediary between a source of power and the object being manipulated. He does not specify where the power originates, as machines can still be human-powered. In that sense, a machine is little more than an advanced tool. However, considering the date of Willis's quote, we recognize that steam engines had already been in use for some time. This was just before the invention of the automobile. The reason we use machines is simple. They allow us to accomplish more in less time. In other words, they increase productivity. Willis mentions three components: the moving power, the machine, and the object being worked on. However, he does not explicitly mention control. While he refers to moving power, such as steam engines, windmills, or human effort, this is not the same as control. Even during the early Industrial Revolution, many machines, such as looms, were controlled by human operators, despite being powered by steam engines. Now, this brings us closer to understanding automation. With automation, we transfer control to a system. Instead of manually operating machines, we implement a control system to handle them. This system consists of two key components: a controller which executes decisions, sensors which provide feedback to the controller, enabling it to adjust its actions accordingly. And that's essentially what automation is. Its effectiveness is directly linked to the quality of the sensors as they serve as the system's interface with the environment. Equally important is how we interpret and utilize the data collected by these sensors. This is what differentiates Tesla, for instance, from other car manufacturers in autonomous driving. While any company can purchase similar cameras, Tesla's ability to process and act on the data is what sets it apart. The degree of autonomy in an automated system depends on what data is captured and how it is used. the concept of autonomy deserves further discussion, which we will address later. The impact of automation on productivity. As mentioned earlier, mechanization and, to an even greater extent, automation has enabled us to accomplish more in less time, leading to higher productivity. This is generally beneficial. However, there is a rebound effect associated with increased productivity, particularly in non-physical tasks. The problem with being able to do more in less time is that it reduces the pressure to eliminate wasteful activities. It allows us to fill our time with tasks that may not be meaningful, such as writing more emails and attending more meetings, ultimately making us just as busy as before. Of course, in most professional settings, we cannot simply leave after 3 hours, even if we have completed the equivalent of 8 hours of work from previous decades. Unlike physical labor, such as assembly line work or warehouse picking, knowledge work lacks objective productivity metrics. Measuring picks per hour in a warehouse makes sense. Measuring emails sent or meetings attended per day does not, as these activities do not inherently create value. Despite this, these activities are often used as proxy indicators of productivity simply because they demonstrate effort. Writing emails and sitting in meetings for 12 hours a day requires stamina, but stamina is not productivity. In fact, you will likely encounter colleagues who are highly active, writing long emails, attending every meeting, and eagerly participating in phone calls and business trips, yet contribute little to actual results. Their net impact on the company's productivity may even be negative, as they consume more resources than they generate. This issue was concisely summarized by Bill Gates. The first rule of any technology used in business is that automation applied to an efficient operation will magnify the efficiency. The second is that automation applied to an inefficient operation will magnify the inefficiency. Productivity versus efficiency. Gates refers to efficiency, while I have been discussing productivity. So what's the difference? Both terms describe the output to input ratio of a system. Productivity can be increased by producing more in the same amount of time, or by producing the same amount in less time, where time is the primary resource. Efficiency, on the other hand, is a broader concept that applies to any input-output relationship, not just production. Simply put, productivity is a specific application of efficiency within the context of production or value creation. Otherwise, the two concepts are similar. A word of caution: if you Google difference between productivity and efficiency, you will mostly find misleading or incorrect explanations. I encourage you to look at some of the search results, but be careful not to take them at face value. Many of them are simply wrong. The limits of efficiency. Finally, while efficiency is an important topic in this course, we must be careful when applying it too rigidly. Beyond the ethical considerations we previously discussed, many aspects of life and business cannot be fully captured through the lens of efficiency alone. Henry Mintzberg has written an excellent article on this subject, which I highly recommend reading. I referenced this article before in our Operations Management course, where we introduced the concepts of productivity and efficiency. Drivers and facilitators of automation. Over the past few years, I have had the opportunity to work with customers on automation projects across various regions, including the United States, Canada, Scandinavia, Germany, Poland, Hungary, Vietnam, China, and Australia. While these companies often differed significantly from one another, the underlying reasons for pursuing automation projects were frequently similar. Understanding what motivates customers to invest in complex and costly automation initiatives is crucial for addressing their concerns and aligning with their priorities. I differentiate between drivers of automation, the fundamental reasons companies embark on these projects, and facilitators of automation, which are factors that enhance the economic feasibility of automation but are not standalone reasons for implementation. Let's start by exploring the key drivers of automation. Drivers of automation. Productivity. Productivity as the core driver of automation. Without a doubt, increased productivity is at the heart of most automation projects in logistics. Accordingly, most business cases are built around improving productivity. As we discussed earlier, productivity is the ratio of output to input, the value created with a given set of resources such as time, energy, or raw materials. A straightforward way to measure productivity gains from automation is by comparing a worker's performance, i.e., picks per hour, before and after automation. However, automation can sometimes eliminate an entire manual task or role rather than simply enhancing its efficiency. In such cases, how do we measure productivity before and after automation? System-wide productivity, not just task efficiencies. This is a critical point. Productivity should not be evaluated at the individual level or based solely on a single automated task. Instead, we must assess productivity across all people and functions in the system. At this stage, I want to draw your attention to our required reading, The Goal by Eli Goldratt. I hope you've started reading it. In Chapter 4, Alex Rogo meets Jonah at an airport, and they discuss whether newly installed robots have truly improved productivity at Rogo's plant. Every time I revisit this chapter, I think I had this exact conversation last week. The situations described in The Goal closely mirror real-world business challenges, ones you'll encounter if you pursue a career in industrial automation. Lessons from The Goal: productivity versus local optimization. In the book, Rogo tells Jonah that the robots have improved productivity in one area by 36%. Jonah then asks, so your company is making 36% more money just from installing some robots? The answer, of course, is no. The increased productivity in one department neither boosted company revenue nor reduced the total workforce. This brings us to a crucial lesson. Optimizing a single function, such as order picking in a warehouse, does not necessarily improve overall productivity. This is particularly relevant when evaluating micro-fulfillment centers, MFCs. These are small-scale automated systems for goods-to-person picking, often based on shuttle technology, are deployed in supermarket backrooms to shorten delivery distances in e-grocery fulfillment. Automation vendors frequently tout MFCs as highly productive due to their superior picking performance. But as we'll discuss later, focusing only on picking speed can be misleading. Productivity must serve the business goal. The conversation in The Goal concludes with a fundamental principle. Productivity means accomplishing something that moves the company closer to its goal. The challenge is defining that goal correctly. We previously distinguished between efficiency and productivity, where productivity is efficiency specifically related to value creation. In The Goal, the term efficiencies is used in the sense of unit economics. Rogo argues that robots reduce unit costs by producing more units per hour, spreading fixed costs over higher output. While this isn't entirely wrong, it's a narrow view. Good unit economics only matter if the company is fulfilling real customer orders, not just stockpiling inventory. This may seem obvious, but many businesses overlook it amid the complexity of performance measurement systems. Employees respond to incentives, so if KPIs focus narrowly on picks per hour, workers will prioritize that metric, often at the expense of overall system performance. The business case for automation. Ultimately, the goal of increased productivity is to make more money, either by selling more or spending less. Cost savings typically come from reducing labor costs, which, as we've discussed, is the natural consequence of technological improvements. If automation doesn't lead to either higher revenue or lower workforce costs, it may have been a wasted investment. Importantly, the goal of a company is not efficiency for its own sake, it is profitability. Efficiency is a means to that end. Automation is just one tool to achieve efficiency gains, but like any tool, it must be applied strategically. Suboptimization, a common pitfall. The phenomenon described in the goal, and one frequently observed in logistics and manufacturing, is called suboptimization. This refers to optimizing an individual process step rather than the entire system. It applies across all material flow systems, whether in warehouse operations or global supply networks. And it's not just a theoretical concept, it has mathematical implications. In optimization problems, a local improvement can sometimes prevent finding the global optimum. Focusing on picking speed while neglecting other processes is a textbook example of suboptimization. Measuring the right metrics. The widespread use of picks per hour as the primary productivity measure stems from three main reasons. First, it's easy to count. Second, it has been a well-known KPI for decades. Third, productivity in other process steps is often harder to measure. However, as Henry Mintzberg pointed out in his paper on productivity, referenced in the lecture notes on Moodle, businesses tend to measure what is easiest to track, not necessarily what is most important. Since automation business cases are usually built on productivity improvements, it's essential to take a holistic view. A positive business case exists if, on average, warehouse or factory employees become significantly more productive across all process steps, not just in isolated activities, leading to a measurable reduction in operational expenses. If cost savings are insufficient to justify the automation investment within a defined payback period, the business case may not hold. However, in some cases, other strategic factors can justify proceeding with automation despite a weak financial return. Next, ergonomics. Productivity is not the only reason for automating material flow systems. Ergonomics can be a crucial factor as well. In some cases, automation is not justified by productivity gains alone, but is instead driven by ergonomic considerations or legal regulations. In such scenarios, automation becomes a necessity rather than a choice. Ergonomics can directly drive automation when certain manual tasks are physically unfeasible without mechanical support. Tasks that require excessive lifting, repetitive movements, or exposure to extreme conditions may necessitate automated solutions. But ergonomics also serves as an indirect driver of automation by influencing labor productivity. Government regulations, union agreements, and corporate policies impose restrictions such as maximum lifting limits per object or per work shift, or time constraints in extreme environments. In deep freeze warehouses, for example, workers must take mandatory breaks after a certain exposure period. These regulations reduce the effective working time of manual labor, making automation a more attractive investment to maintain productivity. Ergonomic requirements vary significantly by country. Some nations have stricter regulations, while others have more lenient policies. Additionally, factors such as unionization and corporate culture play a role in determining the extent to which companies prioritize worker well-being. Scandinavian countries, particularly Denmark, are known for their stringent ergonomic regulations. These requirements extend beyond general workplace safety and influence how automation projects are designed and implemented. During my time in the industry, we frequently encountered challenges when implementing automation projects in Denmark. The ergonomic requirements there are so strict that even previously approved solutions could be rejected in later projects, sometimes by the same consultant who had approved them before. A common issue in such regulatory environments is the emergence of consulting firms or semi-public organizations that effectively act as gatekeepers. These entities may leverage the complexity and opacity of regulations to their advantage, forcing companies to make costly adjustments that go beyond initial expectations. As a result, projects in Denmark often ended up more expensive than anticipated, not due to technical challenges, but because of compliance-related revisions. A good example of how ergonomics influences warehouse operations is pallet storage configurations. On this slide, you see an illustration from a Danish guideline on ergonomics. It categorizes lifting movements based on weight and body posture. Lifting a box directly in front of the body at an ergonomic working height is acceptable. Turning while holding a heavy box is discouraged, as it increases strain on the spine. Lifting a 15-kilogram case at an ergonomic height may be acceptable, but stretching to retrieve the same case from deep within a pallet rack is considered unsafe. As logistics students, you are familiar with the Euro pallet dimensions: 1,200 millimeters by 800 millimeters. The orientation of pallets in storage significantly impacts ergonomics. If pallets are stored long side leading, workers can reach boxes in the middle of the pallet without too much trouble. But if pallets are stored short side leading, they will have to stretch to reach the middle of the pallet, which makes lifting a heavy case much harder. The problem is that for greater storage density, warehouses normally store pallets short side leading. If you're not aware of this and you offer a manual pallet racking system for a Danish warehouse, you might run into a major issue. You could submit a fixed price offer, only to find out later that your proposed racking configuration doesn't comply with Danish ergonomic standards. Now you have two choices. Either you tell the customer that the price stays the same, but they will get about 1/3 fewer pallet locations than expected, or you stick to the promised storage capacity, but bear the cost of adding extra racking heights to compensate for the loss in density. Either way, this kind of oversight can be very expensive. Below the illustration, there's also a section from Danish labor guidelines for cold storage work. These rules have a major impact on warehouse labor planning. At temperatures below -15 degrees Celsius, workers must take a 30-minute break in a warmer environment after every 2 hours of continuous work. The total allowable work time per day in such conditions is 3 to 4 hours. At temperatures below -28 degrees Celsius, workers must take a 30-minute break after just 15 to 30 minutes of exposure. These regulations effectively double the required workforce in cold storage environments, increasing labor costs. While this strengthens the business case for automation, it also raises the cost of automated solutions designed to function in deep freeze conditions. Ergonomic requirements can be both an opportunity and a challenge for automation projects. Strict regulations often justify automation investments, but failure to fully understand these rules can lead to unexpected costs. Companies operating in highly regulated environments must proactively account for ergonomic compliance to avoid costly redesigns or legal complications. The next driver: quality. Another important driver of automation is quality. Like performance or productivity, quality is a term we use frequently without always defining it. In fact, we could dedicate an entire course to quality management, but in the context of automation, we can keep it brief. Quality is often assumed to be universally understood, yet its meaning is highly subjective. We talk about quality food, quality services, or quality products like cars, and while the definition remains vague, people generally understand each other. However, What qualifies as high quality depends on the criteria used. A fashion expert might dismiss my expensive brand name shirt as low quality based on fabric composition and stitching, even though I assumed it was excellent. The same holds true for products like cars, where one aspect, such as engine performance, may be outstanding, while another, such as interior materials, feels cheap. If that engine breaks after 50,000 kilometers, but the supposedly low-quality interior lasts 1,000,000 kilometers unchanged, was it a high-quality car or not? Although quality is subjective, once properly defined, it can be measured objectively. In the context of manual versus automated processes, we typically look at concrete quality metrics such as picking error rates and product damage. These are critical because they shape customer perceptions of a company's products and services. A picking error occurs when a warehouse worker selects the wrong product for an order. The error rate is the number of incorrect picks relative to the total number of picks. This rate varies significantly across industries. In some cases, picking the wrong item or the wrong quantity, like an extra piece of candy, is not ideal, but not catastrophic. In others, such as pharmaceuticals, a picking error is unacceptable. The financial and reputational cost of such mistakes can be severe. Automated picking systems, whether fully robotic or goods-to-person, can virtually eliminate picking errors, directly improving perceived service quality. Product damage is another key concern, and in some industries, it has become a bigger issue than picking errors. For customers, it's difficult to distinguish between damage caused in transit and damage caused by careless warehouse handling. The impact of automation on product damage isn't straightforward. It can reduce or increase damage depending on the system. Conveyors, for example, can be rough on goods. One online supermarket I spoke with reported a significant breakage of certain products after implementing an automated system. To prevent damage, additional measures such as padding, dividers, or modified load carriers may be required to prevent fragile items from moving too much during acceleration stops or turns. While reducing picking errors and product damage contributes to a stronger business case for automation, these factors alone are rarely sufficient to justify the investment. Their impact can be quantified, or at least estimated, but in most cases, they support automation rather than drive it outright. But let's talk a bit more about quality. We can summarize quality as follows. Quality is subjective. Perceptions of quality depend on knowledge. Experts or producers often understand a product's quality in ways a layperson might not. Quality depends on the aspect being evaluated. For example, some might call a Dacia a low-quality car. But is it really? A Dacia is an affordable, practical vehicle that serves the commuting needs of most people. If it fulfills its purpose effectively, can we still call it low quality? The same applies to food. Some foods taste great, but are loaded with preservatives and unhealthy additives. Others are extremely healthy, but taste awful. Which one is higher quality? Ethical considerations also play a role. Was the food produced under humane conditions, or does it come from unethical mass farming? Beyond the product itself, we can evaluate quality from various perspectives. Health aspects. Is the product beneficial or harmful in the long run? Environmental aspects. Does it have a sustainable footprint? Ethical aspects. Consider supply chain ethics, such as labor conditions in manufacturing. Time-dependent quality. A product may be flawless for 3 years, but deteriorate rapidly afterward. Methodological quality. Is a product designed in a simple, reliable way, or does it achieve the same function through unnecessary complexity? Simplicity often means fewer failures, yet if simplicity defines quality, why do people buy expensive mechanical watches, when a cheap digital watch tells time just as well, if not better? The answer lies in perception, just as in art, where part of an artwork's value comes from how it was created. Process quality. A product may be well made, but if its production process is inconsistent, quality suffers. Consider Mercedes-Benz. At one point, cars coated when the primer bath was freshly refilled had exceptional rust resistance. While those cars lasted decades, the variation itself was a sign of poor process control, evidence of flawed quality management. So what is quality? Defining quality is challenging. It is subjective, multidimensional, time-dependent, and context-driven. In daily conversations, people often understand each other because they implicitly share the same notion of quality in that specific moment. But disagreements arise when people operate with different definitions of quality, not because the facts differ, but because their perspectives do. If you take one lesson from this discussion, let it be this: understanding quality in its many dimensions will sharpen your ability to critically assess any quality-related initiative or strategy in your organization. The American Society for Quality, ASQ, defines quality as the totality of features and characteristics of a product or service that bears on its ability to satisfy stated or implied needs. This definition is broad enough to cover the aspects we discussed, but its breadth is exactly why you must remember the nuances. Quality is never just one thing. It is always a combination of perspectives. Let's move to the next driver of automation: theft and breakage. Another factor that can drive automation is theft and breakage. If you've ever worked in a warehouse, and I highly recommend doing so for a few weeks to gain first-hand experience, you'll know that it can be a tough environment. If you're looking for a holiday job, consider working in a warehouse. It will give you valuable insights. In some warehouses, workers receive performance-based bonuses for achieving high pick rates. This creates pressure to work quickly, which sometimes leads to rough handling and accidental damage. However, as we already discussed in the context of quality, product breakage is usually unintentional. Deliberate damage to products or equipment is rare. For some industries, theft is a far bigger concern, especially for high-value items. To mitigate this, companies often store valuable goods like tobacco, alcohol, jewelry, pharmaceuticals, or precision machine parts in restricted access areas. These items can be worth thousands of euros, and if they can be picked, they can be stolen. Conducting security checks, such as frisking employees at the end of their shifts, is costly, time-consuming, and negatively impacts employee satisfaction and trust. Automation offers an alternative. High-value products can be stored in automated systems, restricting manual access. When picking occurs at goods-to-person stations, security measures can be implemented more effectively and with less disruption. In some cases, picking can even be fully automated. Advances in piece-picking robots capable of identifying, grasping, and placing individual items of varying shapes, sizes, and weights, have made fully automated picking increasingly viable. As with quality, theft and breakage alone are rarely strong enough reasons to justify automation, but they can strengthen the business case by reducing losses and improving security. Next up, scarcity of labor. While automation is often discussed in the context of cost savings and efficiency, an increasingly relevant factor is the availability or lack of workers. This point is related to, but identical with, productivity as a driver of automation. Let's start by looking at the graph in the background of the slide. This graph represents unemployment rates over time for 4 different countries: Hungary, blue; Germany, light blue; Netherlands, purple; Czech Republic, green. We can observe that in all these countries, unemployment has steadily declined over the years. In particular, the Czech Republic has one of the lowest unemployment rates in Europe. This means that businesses in these regions are struggling to find workers, leading them to seek alternative solutions, such as automation. And this is in spite of the fact that countries like Hungary and Czech Republic have relatively moderate labor costs by our standards. Traditionally, automation has been justified through a financial business case, reducing labor costs, improving efficiency, or increasing throughput. However, in economies with consistently low unemployment, businesses face labor shortages, which means automation is sometimes adopted out of necessity rather than just for cost reduction. Industries such as logistics, manufacturing, and retail are particularly affected. Companies have no choice but to automate processes because they simply cannot hire enough workers. Now, of course, if you increase worker productivity, you need fewer workers to get the work done, which decreases the problem of labor shortage. That's why I said the two problems are related. Another way to address the problem of labor scarcity that's simple yet rarely discussed: just increase the pay. Instead of spending millions on automation, you pay warehouse workers some euros more, which increases the likelihood of them wanting to work for you. Not so difficult, right? Of course, you will still have to deal with sick leave or other reasons of absence, but it allows you to continue your business. Facilitators of automation. Let's shift our focus to the facilitators of automation. Factors that support the business case for automation, but are not, by themselves, sufficient to justify investment in automation technology. Think of these facilitators as conditions that make automation more viable. A company might want to automate, but if these conditions are not present, the business case might not be strong enough to proceed. Facilitators of automation are conditions that either support the financial and operational feasibility of automation, may be required for automation to be effective. However, just because these conditions exist does not mean automation is always the right choice. They are necessary but not sufficient. Other factors like cost, scalability, and risk also play a role in the decision. Now let's go through three major facilitators of automation. First, long operating hours. One of the most important factors that makes automation more viable is long operating hours. Automation typically requires high initial investment, so for it to be economically justifiable, companies need to maximize their utilization of the system. If a facility operates only one shift per day, automation may not deliver a strong return on investment. However, when a facility runs for 2 or more shifts per day, automation becomes significantly more attractive. The reason is simple. The fixed costs of automation, such as system installation, maintenance, and depreciation, can be spread over more hours of operation. Example: consider an automated picking system in a warehouse. If the warehouse runs only 8 hours per day, the expensive robotic system may sit idle for the remaining 16 hours. This significantly reduces cost effectiveness. But if the warehouse runs 2 or 3 shifts per day, the system operates for a larger portion of the day, making automation a more viable option. Second, long order lead times. The second key facilitator is long order lead times, which help distribute workload more evenly across operating hours. Many businesses experience demand peaks, requiring them to handle large volumes in short time frames. Automation works best when workloads are predictable and evenly distributed. If order lead times are short, e.g., same-day delivery requirements, automations may struggle to respond flexibly. In contrast, if a business has longer lead times, it can schedule work more efficiently and reduce the need for expensive peak capacity. Example: A manufacturer with a just-in-time supply model may struggle with automation because demand is unpredictable and flexibility is required. In contrast, an e-commerce fulfillment center that guarantees 3-day delivery can smooth out workloads over time, making automation more feasible. Third, stable order profile. Finally, automation systems perform best when they operate in an environment with a stable order profile. Most automated systems are designed around specific order characteristics, e.g., SKU mix, package sizes, or picking patterns. If order profiles change frequently, the system may become inefficient or require constant reconfiguration. Businesses with stable and predictable order patterns benefit the most from automation, as the system can be optimized to handle a consistent workload. Example: an automated storage and retrieval system, ASRS, in a warehouse is optimized for a set of regularly ordered items. If the product mix changes dramatically, e.g., due to seasonal demand fluctuations or new product launches, the system may become inefficient. However, if demand is predictable, automation can provide significant efficiency gains. To summarize, automation is most effective when operations run multiple shifts per day, maximizing system utilization. Orders have long lead times, allowing workloads to be smoothed out. The order profile is stable, ensuring system efficiency over time. While these factors support automation, they do not automatically justify it. Businesses must still evaluate costs, risks, and long-term flexibility before deciding to automate.